This last day of our Nextflow Summit. Thank you for getting up. I know it was a late night last night. I hope you all had fun. And if you've got a lot of caffeine or tea or whatever your beverage of choice is to give yourself a boost in the morning. We have a wonderful session this morning, two more sessions. This first session, we have 5 lovely talks for you. And thank you very much to those of you, our speakers, who are going to be kicking us off this morning. It's always hard to be the first speakers on the last day of the conference, especially after a very fun social. So thank you all for making it. Hello to those of you who are watching the live stream from your hotel beds. The brave ones are here. So we're going to kick it off this morning with Felipe and Juliet, who are going to talk to us about contributing to the NF Core project through client collaboration. So if you'd like to join me, we'll kick it off.
All right. Hi, everyone. Good morning. I hope everyone's having a great morning after yesterday's wonderful dinner. Before I start our talk, I just wanted to start out by thanking the organizers for the wonderful summit that we've had so far, as well as giving us the opportunity to speak today. So my name is Juliet Follickson, and I'm a bioinformatician, as well as a bioinformatics manager at ZS Discovery. And I have the pleasure of sharing our talk today with Felipe, one of the bioinformaticians at ZS Discovery. In the first part of our talk, I will be introducing you to ZS Discovery, what we do, as well as the type of projects that we offer our clients. And then Felipe will follow up in the second part of our talk and actually walk you through one of these client projects where we worked to customize the NF Core single-cell RNA-seq pipeline to fit our clients' research goals. All right, so let's get started. So at ZS Discovery, we work closely with our clients within the early part of R&D to work, and these clients include, for example, pharmaceutical companies as well as biotech companies. And we work with their R&D departments to enhance and accelerate the R&D successes as well as capabilities in areas such as target discovery and data and knowledge management. And just as we at ZS Discovery work closely with the early part of R&D, we have other practice areas that work with other parts of the drug discovery development pipeline, such as medical affairs, as well as clinical development. And at clinical development, what they do is they work with clients to be able to enhance their clinical trial capabilities, both with design as well as operations. And now if we take an even broader look at ZS, ZS is a global services firm that is made up of over 12,000 individuals spread across 35 offices around the world. And over the last 40 years, we've become an end-to-end solution provider for both the life science as well as the healthcare industry. All right, so now back to ZS Discovery, which is where the two of us are located. And as I mentioned early on, we work with the early part of R&D, and we offer our clients these 4 different types of projects. And we have a special proven track record for target discovery, as well as data and knowledge management. So for target discovery, we know that to find novel drug targets, we leverage advancements in both science, data, and technology to be able to find the targets that are supported not only in a biological systems level, but also with disease biology, because this will increase the probability of a successful drug discovery project. And now, if we move on to our data and knowledge management offering, which is actually really pertinent and very relevant for the summit that we're at today. This is where we work with data to collect it, analyze it, synthesize it, and present all of the relevant and key information. And in order to be able to do that, because we are biologists as well as bioinformaticians, we're able to work closely with our clients to get a good understanding of what their actual end goal is, and then help them design the process to get there as well as implement it. And this includes figuring out what kind of data it is, collecting it. This could be their novel internal data sets, but also going out into the rich public sphere to find the relevant data to fit the problem at hand. And so once we have collected the data, we then work to design and implement automated pipelines to clean up, analyze, and get the key information from the data and present it in both an intuitive fashion, but also a standardized way in things such as with Shiny apps, so that our clients' own scientists are able to dig through the data themselves to be able to develop as well as validate their own hypotheses. And then the other two offerings that we have are precision medicine. So this is very relevant in today's time and age, where we work to find the right treatment for the right patient at the right time. And finally, the last offering that we have is also the research strategy and transformation. All right. So to be able to help our clients face the challenges that they face, as well as deliver on all of the projects that I have presented to you, we span a range of different capabilities, as you can see here, as well as expertise. We employ various apps, and we're also able to analyze, but also understand various data sets and integrate them. And the only way we're able to do that is because we have a team of over 110 individuals. So we're an interdisciplinary team, and we like to call ourselves molecular natives because we truly want to understand the data that we are working with, not only from a technological point of view, but also the biology captured in there. But our team spans PhDs, medical doctors, bioinformaticians, computational scientists, statisticians, machine learning experts, and so on, and also people with wet lab experience that all work together on various different client projects. Additionally, we still routinely publish in peer-reviewed articles, and we do that not only through client collaborations and as a result of client work, but also because we like to stay connected to the academic ecosystem, and we still have a number of different partners that we work with in academia. And not only does this help us stay in touch with what's happening in the research world, but also helps us stay innovative for our clients. And so now we're coming to the end of the first part of the talk, and this is when I'll start wrapping up. So to finally just repeat, the types of clients that we work with are pharmaceutical companies, which range from large pharma to mid-sized pharma, but also biotech companies. And in order to make our clients' lives easier, as well as our own, we have come into a range of different partnerships. And one of them, which is very pertinent for, again, the summit that we're at today, is Secura Labs, which through having this partnership, we're able to deliver more value to our clients. We're able to more seamlessly integrate solutions for them to get things up and running faster. And this is where Felipe will take over, and we'll show you an example of how this has happened. All right, Felipe, over to you.
Hello, everyone. Thank you for being here this morning after some party. I hope you're all pumped for today. Today what I'm trying to give us a brief showcase to you is like how the words of open source and let's say closed source can collaborate between each other, in a synergic way. So going to just showcase what happened like in this collaboration with Bohinga Ingehai that we had, where we needed to use, they needed to have something to analyze the single-cell RNA-seq data. And for that, I mean, there was already something inside the client's mind as well. They needed and they wanted to use the single-cell RNA-seq NF-core. And I mean, I don't think I should give more reasons to like, because it's a gigantic community of people using it and making these things like follow all the best practice analysis you can do for single cell. So it just makes sense to use this pipeline for the data, for the analysis in the client, and not reinvent the wheel if things are already there. But like, although the pipeline already like provides all this core analysis like that we need for the single cell RNA-seq data, the thing is, which is just ground true, like institutions will never be the same. Each one has its own reality. Each one has its own set of data or type of, let's say, layered database that they need to communicate with. And this was the reality, for example, in BI. So this is like these three things is just trying to highlight how things were done and why the collaboration was needed. Because they were already using the single cell RNA-seq pipeline. It was giving the results they want. They were pretty happy with that. But the thing is, they needed, because all the data, they need to follow data protection rules. They cannot have things in public databases or like stored in places where the NF-core pipeline is already like standardized to use it. So they had like a set of scripts, for example, which was the upstream processes that they had to communicate with this internal database of theirs. So they could fetch the data, store somewhere like in a bucket, because yeah, depending on where your data is, sometimes the data cannot leave that country. So all these first processings to let's say have a sample sheet ready to run the pipeline. So then once you have the sample sheet, of course, the pipeline was triggered, and then once the results were there, there was also some downstream processes that needed to be done, like because just having the data, just having the matrices was not sufficient for them, because who needs to see these results as the physicians is like the actual people that need to take care of these data, like need to interpret it. So in the end, there was still like some other scripts to make to work with these matrices, like to have some summaries, some statistics summaries that were relevant for the client, and then to finally upload it back to their internal dashboard where the physicians, where the people that need to see the data can actually see. Because giving them the files, it means nothing. They need to have that on the dashboard. And that's like something that they already had. But the things that they had that in a set of scripts, which, yeah, they were doing these things in 3 steps. And I mean, this is great. This was working for them. The main problem with that's like because you have these steps of manual work, it's not easy to scale that up. It's not easy to productionize that, and that's where the collaboration came from. Because the result, like what was actually needed, is that we needed to internalize these manual steps as a single thing in the pipeline. So then you can have a single thing, a single execution pipeline that then it can be scaled up easily. So this was the internal, this is, let's say, the main goal of the collaboration. This is what was needed outside the collaboration. This is what was given to the client. So in the end, we had what we need to do, like this is, let's say, the major step or the major barrier, the hindrance that we had to overcome first was like, how can we internalize the single cell pipeline? How can we internalize this NF-core pipeline? But in a way that we can customize some stuff that does not make sense to go to the public, because, for example, it's like just for these institutions. but still be able to fetch whenever a new update from NF Core was released, we could get these new changes and update the pipeline internally without conflicts. And the actual answer is we'll never have not have conflicts. We will always have conflicts on merging them, but the thing is that you can make them less. You can make them very minimal. So this was the first step. We realized we could do this internalization, allowing Git unrelated Git histories merging, and that happened. So on the way, we had this final project, this final pipeline that could do all those manual steps in a single execution. Now things are actually they are ready for the secure platform, which was so-called NF Tower. That's why you see that in the slides. But yeah, and now the actual way of executing it, it's way easier for the client, because instead of all those menu steps, they can just go to the pipeline and say, I want to analyze study 100. Then it knows how to figure that out. But you'll see that I'm not showing any of those things to you, because that's not the actual goal of this talk. This talk, the actual goal of that is to try to pump up the open source community, the wonders of Nextflow and NF Core itself, because all these was only able to happen because of that the pipeline is in DSL2 and that DSL2 was integrated. I need to highlight that, because even though that is not something very new, you'll still be amazed if you try to Google how many DSL1 pipelines are still out there. And this just makes sense because sometimes you just don't have the resources to do the conversion, which is not seamlessly done. And then, of course, the NF Core community. The NF Core community, by adopting the DSL2 in most of the pipelines and also making these collaborative communities, this is what actually make all these things happen. But then, so far, I've been telling, okay, this is how we benefit from the community, but what does the community get with that? So that's the actual endpoint where we want to highlight that, this is not supposed to be a one-way thing. It's not just to close the source that should use what is open and that's it. It should be a synergic, a mutualistic association between these both communities, let's say. And this is what we wanted to integrate. If you see today the collaborative history, the commit history of the pipeline itself, of the repo, following all the BI's needs, all the specifications, everything that they wanted. We did also pushed back a lot of commits to the community, because, for example, when doing the analysis, we are also facing some stuff we need this thing. Let's say we need this matrix conversion. This is one thing that we added there, for example, to CREDs, to H5AD, or whatever to use with other tools. And then we saw that in the GitHub, in the public repo, these were also an issue open there. So instead of just adding in our internal copy, we are actually adding these modules in NF Core modules, then pushing it back into the single cell, because we could separate what changes we wanted could be public and what changes we wanted should not be public. But then, this is the actual main source, and I think the goal of the whole talk is I think that closed source communities, companies, or the private world, the pharma world, can benefit from it, but also I think by this happening, the open source community can also gain a lot. And I would like to finish it by thanking everyone, and because to put names in the slides would not fit in just one slide, we decided to just put the names of the organizations, and I want to thank everyone for making all these happen. Thank you.
Thank you so much. That was really interesting, interesting talk. It's a really interesting model for kind of driving innovation and improvements. We have one question for you from Slack. Was your client ever hesitant about you putting work into an open source project?
Nope.
Wonderful, excellent. Wonderful clients. Another question for you. How much customization was required to get the pipeline working with Tower, which is now Secure Platform? Was this simply standardization to an core scheme?
Yes, I mean, there was actually no trouble at all. I mean, because the pipeline, the NF core pipelines, they are already ready for Secure Platform. By using the schema and all, I mean, whatever we added for the private world, let's say, like whatever we added for this internal database thing, and we needed new parameters or whatever, we just needed to follow the same standard. But I mean, there was no issue. Yeah.
Got it. There are more people typing in the Slack, but we'll thank you for now. And if you'd like to continue the conversation, I think there's a lot of interest in the model.
Yes.
So thank you very much for your talk once again.
Thank you.
All right, next, we are going to have Guoying Qi talking about decoding the tree of life, which is a very large scope. So we're looking forward very much to that.
Hello, morning, everybody. My name is Guoying. So I'm from Wellcome Sanger Institute in Cambridge. Yeah. Today I'm talking about how we use Nextflow in Tree of Life program. Yeah, Tree of Life program. So first, what is the Tree of Life program in Sanger? So this is part of the Global Biodiversity Sequencing Project. So our aim is to sequence all the complex life forms on the Earth to produce a very high quality genome for each individual species. So this will help us in the conservation and understand the interconnectedness of the life and build a new economy based on biology materials. Yeah. So this Tree of Life program including many projects. So one of the first project is called the Darwin Tree of Life. So Darwin Tree of Life is going to sequencing all the 70,000 of species in Britain and Ireland. And so far, in July, we already submit 1,000 of complete genomes to the as the genome notes publication. So that's the Tree of Life program. Oh, sorry. So this our whole process we call the genome engine. We stopped from collecting the sample from the field, then extract the DNA, doing the sequence. We use different technology, Pacbao, Illumina, or Oxford Nanopore. Then we do the assembly, genome assembly, and the curation. Then the final product is published genome notes. We also submit the complete reference to the ENA and at the same time in the ensemble as well. So that's the whole process. So as us, the informatics team, we mainly respond to the 3 blocks here, the assembly, curation, and the genome notes publication. So that's 3 blocks. So our informatics team responds for. So this we call the data processing pipeline. So that's the main task here. So the raw reads, we normally, after the sequencing machine in the iROS system, we need to download that raw reads and pre-process them, decontamination it, and do the assembly. Then we run some standard genome analysis pipeline to generate the results for the people to use. Then the final task, we automatically generate the genome note publication to publish the results. So that's the data processing, the whole pipeline. We have a few tasks here. So we are going to write the pipelines to deal with these steps. So here, we adapt the Nextflow to write our pipelines. So we follow the NF core guidelines very strictly. So all our pipelines update the template very often. So currently, probably NF core 2.8 or something. Yeah. So this is pretty much so everything here. So we use all our modules is pushed to the NF core. So currently we have lots of sub workflow for each pipeline as well. We not publish them yet, so we will publish the sub workflow as well. So currently, we have 12 pipelines released of under development. So we have a pipeline portal to make all the pipeline together here. So this portal, actually, we use the NF core website. We exactly copy. I just modify a little bit, switch the NF core Git repository to our Git repository. So that's why, so all the features from the NF core website will be available in this website. I will quickly show you what that look like now. Oh, sorry. Oh, not showing here. How to show this the web page to on screen? Okay, go back. Just look at the screen. Okay, you're probably familiar with this looks like the NF core website, yeah? So yeah, so this is all our pipeline here. Yeah, so this is one of the pipeline called the read mapping. So you can see there's a few tabs here. The introduction, actually the README page in the GitHub repository. We have a result page to show the testing results here, exactly that NF core website. We have a different page, use the NF core website, yeah? So we also have, sorry. So this, you can see lots of numbers here. We have 19 contributors in all our pipelines. So all these numbers you can see here. Okay, so that's the different pipeline, different people to commit here. So this is our release pipeline. You can see how many releases, how many unique committed. So currently we have basically our team around 11 people. So develop all these pipelines. We have 9 pipelines released here. So yeah, so everything we copy from the NFL core website. Yeah. Okay. Sorry. Okay, thank you. Okay. So that's our pipeline portal. So I showed you this page, that this page also showed, yeah. So except the pipeline portal, you can find all our pipelines in the GitHub repository as well. So our organization name called Sanger Tor. Tor is Tree of Life, yeah. So yeah, so all the pipeline available in MIT lessons, you can download or modify them. So, and also, so our pipeline is fully tested. There is 2 tests configured in GitHub Action. The first test is the small test that will be run in the GitHub runner. So anybody can run this test if you download the pipeline in your local. So another test is a little bit bigger testing. So this testing will run through the tower, then actually execute in our farm. So this will make sure our pipeline is fully testing in our environment. So then the results, you already see the results. We archive to the Sanger S3, then you show the results in the pipeline web portal. So yeah, so you can come to here to look at our pipeline as well. So before writing the Nextflow pipeline, we need to pack the software. This kind of decision tree, how we pack our software. So we normally prefer the Docker image against the Singularity image. We don't build the Singularity image directly. We only build the Docker image. So first we find the Docker image in any public repository or not. If there's one, we will use it. Especially we go to the Bell container first to find any image there. So yeah, we prefer the Bell container image against the other repository. If not, so we will write our own Docker file, then build our own Docker images. So this is the decision tree, how we pack our software. I'm sorry that the title is a bit. So this is the repository to centralize all our Docker file. So each software, we have a subdirectory there, normally only with the Docker file there. We also have build a Docker image permit file to define what version this software is, and also container version, because sometimes the software not changed, but you just want to add something in a different way to build the Docker image. So we also version our container version plus the application version. Then later, we will tag the Docker image in this way. So the application name, like this air gray 3.0 container 1. So this how we tag the Docker image. So most image we push to the KL, so that's make public, so everybody can use our Docker image as well. So currently, the Docker file keep in our internal GitLab repository. We have a GitLab CI. If you add a Docker file there, so that the GitLab CI will automatically build everything and push it to the repository. So once the Docker image is being built, we will expose the Docker image in our farm. So you can use or testing the software before you write in your pipeline. So we use the SHPC to deploy our Docker image as a Singularity image on the farm. So this is kind of very easy with the SHPC's help. So first, you have a SHPC recipe file, define which Docker image to use, and what version. You can list any version, the Docker image version there. Then you can list what binary or script you want to expose outside of the Docker image available from the farm. So that's the Docker image, the SHPC recipe file. Once you have this recipe file, it's very easy. You just use the SHPC install this software. So then this software will available through the module. You just use the module, load this software. So all the binary or script will be available on the farm. So yeah, so thank you for the SHPC. So that's the whole process. We have the Docker image, SHPC will convert to the Singularity image, then the Singularity content will be run on the farm as the module. We load the module to use the software. So that's how we pack our software and deploy our software before writing any Nextflow pipeline. So you can see we have a very big list of genome or spaces to run. We have lots of pipelines for each species to run as well. So how can we manage these things? Currently, so each day each week we run 20 or 30 species with different pipelines. So how can we manage here? So we have a database, workflow database, to centralize all the workflow we run or running or going to run. So that's a database we tracking everything there. So on top of the database, we have built an API, so you can trigger the workflow run through the API or through the Docker, through the command line, actually. So this is a workflow API through the command line or API. So here, so all our input actually from Jira, we tracking all the spaces on different stages use Jira. So the Jira, so you have a Jira ticket, a different project. You have a different list in the Jira. So we continue monitor Jira, different stage, we trigger different pipeline. So input the Jira, everything we keep in the database, workflow database. How we link them together, we introduce another concept called the prefix. So the prefix is another lightweight workflow. So we use the prefix as a workflow to control how we run our pipeline, how we tracking them. So the prefix, we introduce the prefix here. So the prefix will talk to API to submit the workflow to run or resubmission this kind of thing. So prepare the we have input templates. So go to the Jira, you get the spaces. So you fill the template, so then you get the configure, the input for Nextflow. We pass to the Nextflow for this configure. So then the prefix through the API actually run our Nextflow run on our farm. So currently, we are trying to use the tower in different way. But at the moment, we just try to send, when Nextflow run on the farm, we just send our logs to the tower. Yeah, so later you can easily to look all the next thing the tower provided. So actually, we have another thing that we also send all our Nextflow logs to Elasticsearch So then it's easy to us to analyze all the next, so what memory we being requested, how many being used, these kind of things. We have another block somewhere. So that's, we use Perfect to control everything here at the moment, not directly use Tower yet, yeah. So this is what the Perfect. The Perfect is a very lightweight workflow, complete writing in Python. You just, if you're familiar with Python, then it's very easy to write this kind of flow. So in Perfect world, they not call the workflow, they call the flow. The flow including subflow and a list of tasks. So yeah, so that's the Perfect. Yeah, so lots of tutorial online, you can find it there. So this is what our Jira is like. So this Jira is in one of the projects. You can see there's a list, a very long list of the species with the Darwin tree project, which project with lots of other ID follows. So each line is represent one species. We will pick up this line from here to trigger our list of pipeline. So this is the input of our workflow. This is one of the dashboard for the Perfect. Here, you can see what is the Perfect flow. So you can filter out the results. So we have one of the flow called pipeline orchestration. So this flow, we have 4 deployments. What is the Perfect deployment? The deployments is define what to run, where to run, and how to run it. So the Perfect is, so this is the Perfect server. So there's a worker also installed along with this in Kubernetes cluster. So the worker actually doing the work. Then, yeah, so finally they will trigger something on our farm to run. So you can see the first is auto scheduling. So every 30 minutes we will go to the Jira to fetch what I can do. So then trigger the workflow, all the pipelines on the farm. So later, if any job failed, you can resubmit your workflow from here as well. So on this corner, you can see the last deployments. I show the sub-menu here. You can quick run this deployment or custom run. If you put a different work directory, so you can configure to run this deployment yourself. So this is the Perfect dashboard about the workflow and deployments. So this is the run page. So you can see over these 3 days, this flow, most of runs take 9 seconds. You can see all green means all our run is successfully. Some take longer. If you click that dot, you can see the actual logs underneath. So last bits, there's some red spots there. This run failed. We were testing something that run failed. You click, then you can find the loggers here. So here the logger is the Perfect flow logger, not the Nextflow. The Nextflow logger will, you can see them on our farm directly or on the tower. So here is the Perfect flow log. If you click one of the spots, the actual run page, you can come to here to check the run. So this run, there's 2 sub-workflows. On the top, the green bits is the timeline. The first sub-workflow, there's some task there. You click each task, you can see each task log as well. This is a very messy. This is another run. You can see lots of red parts here. That's a failed run. You can read the information why the run is failed. Yeah. So this simple UI for our workflow. You can see what spaces, which workflow run, in which version, on where to run status here. So that's a very simple UI. Yeah, like I said, currently we have 4 pipelines running in production, about 20, 30 species per week. Our target is 60 species per week. Integrate all the pipelines in this way. So everything is still just started. We're still testing and refine everything here. So finally, I will thank our team. The Matthew is our team leader. The Priyanka developed several pipelines here. She also, as the Nextflow ambassador in Sanger campus, she did lots of code review, training, hackathon about Nextflow. Sabin is actually the prefect's flow and the API, the workflow API. The Beth did the genome nodes pipeline and make the genome node publication automatically. So finally, everything we follow the Nextflow. Thank the NFCO, the whole community. Yeah. Thank you.
Thank you so much. This is a fascinating project, and the scale is pretty mind-boggling. There are lots of questions, especially about the scaling and the technology in Slack. So if you don't mind joining the Slack afterwards, I think we'd love to get a little bit more from you. But for now, we're out of time for questions, so we're going to move on. And Marcel, my teammate, is going to talk about his experience as a developer advocate over the past year with the Nextflow community. Thank you.
Hello, everyone. So this experience of building a community in Secure, building this Nextflow and NF Core community has been very, very nice. It's been, first, a very easy thing to do, because as you can see, we have this amazing community way before I even appeared, and at the same time, very hard, because if it's so great, how can we help make it even better, even greater? So I think there's no way better to start this talk and saying thanks to all of you, otherwise I would not be here. Like, this community is amazing. From the very beginning, when I joined the community, everyone was very helpful. I wasn't an expert in Nextflow, so I indeed need a lot of help, and you all been very helpful. So everyone I helped today, I tried to remember at the beginning when I was there and was needing this help, and it was great. So as I said, when I appeared, Nextflow was already here, the community was already large, there were lots of activities. In terms of education, we had the training material that employees at Sequera created and made it public so everyone could use it to learn Nextflow or train other people to know Nextflow. We had the training at the Carpentries Incubator by Satish Perry, so very nice source of information also. We had all the places on the internet where you could find how to learn Nextflow, how to learn NF Core, and all these things. We had NF Core bite-sized talks to learn about Nextflow and NF Core too. And we had a mentorship program. The first round was already occurring, and a lot of people around the world were benefiting from this initiative. So as you can see, a lot of things were already going on. We had Nextflow events, we had NF Camp and NF Hack. There were some NF Core hackathons, the bite-sized talks, you can consider them an event too. So all this before I even appeared in the community. So a lot of stuff was going on. It was very nice. It was a lot of source of information for me to learn about Nextflow, to learn about how you all been working with these tools. And it was great. Definitely it was great. But at the same time, there were some pain points. Like the first thing was geographical reach. I'm from Brazil, and I did my master's degree in bioinformatics, and I didn't know about Nextflow. And I regret so much about it, because I could have done so much more if I had Nextflow and if I knew NF Core. So there was this thing that NF Core and Nextflow, they were mostly in North America and Europe. And if you go far from that, either people don't know about Nextflow or they use it in an isolated manner. They don't connect with the community, don't organize events, there are no talks. So of course you have people using Nextflow everywhere, but it's much more easier to have events in North America and Europe. The second thing that I saw that could improve was about Q&A and discussions. So at some point, we would have Google Groups, and people would even think that Paulo was a robot because he was answering all the questions all the time. And like yesterday during the dinner, everyone was having food, and in my Twitter, Paulo had just answered a question like 2 minutes ago, so he never stops. So after Google Groups, there was GitHub discussions, Gitter. Eventually, we land in Slack. And there are many benefits about Slack. We have threads, for example, but a lot of people, they don't use the threads. And even though you join Slack, for example, you want to ask a question, and you try to search if anyone has asked this before, even if you are willing to do that, it's very hard to search content on Slack. So in the end, what we have is every day people are asking the same questions. And this is not, I mean, even for them, that's not nice, because they are like, okay, definitely someone already asked that, but I searched for that and I couldn't find. At the same time, this has been a great experience. Like in the past 1 year, I've answered 429 different individuals, like over 700 questions. And this is just an amazing way of getting to know the community and seeing how we can help, even with Slack and its limitations. The other thing is that we have a lot of training content, as I said at the beginning, but some of them were DSL1, some of them were already DSL2, or they were converting, and it was very decentralized. So, of course, we can have like Learn Nextflow in 2023, like we have now a blog post with all these different links you can go to learn Nextflow, but it's very decentralized, it's difficult to maintain, it's difficult to find for beginners. So we had lots of great content, lots of great people doing amazing things, a large community, but it wasn't very centralized and organized. If you're already inside it and you're an experienced user of Nextflow, you can find everything. But if you just arrived, it was very hard to find content. And the community was amazing. I said this multiple times. There's a lot of people, but there was clearly much more we could do to support the community. As community members, as a company like Sequeira, who supports the community a lot, and people who were like in the core team, for example, clearly there was more that we could do for the community and for new people. So again, it's great. There's always room for improvement. That's the paradox of my job. It's easy to be a developer advocate for you guys because it's already an amazing community, but at the same time, it's so hard because we have to make it better, and it's not easy. I've been an ambassador in other open source projects before, and I have to say this one is different in all the good ways. So one of the first things we did, and actually this started slightly before I joined Sequeira, but I was already volunteer to that, was the first thing was to update the Sequeira training material that was publicly available to DSL2, to update it, to make it better, which was, again, a hard job. There were like thousands of comments. People were already working on this training material for years, for so long. So, I mean, we already got something with a very high quality, but we had to update to DSL2, we had to make it better, we had to organize it, and so on. After we did that, we have this idea of having a hub, a community portal. And then, instead of being training.sequeira.io, we moved to training.nextflow.io, where we hosted the famous basic training of Nextflow, which is very complete and helps you from zero to hero, let's say. Afterwards, we realized that a lot of people were asking about localized content. So they wanted trainings in French or Portuguese or Spanish, in other languages. And then we started to do this. So basically now if you go to the training material, you have all the trainings in English, in Portuguese, and they are partially translated into French and Spanish. So now we have this basic training. We have now a hands-on training, which is like, you know a bit of Nextflow. It's been a few months or years, you don't use it. You want a quick training just to get you up to date and remember all these details. You go to the hands-on, which is very short training. And then we have the advanced one, which was contributed by Rob Simon. Amazing training. If you already know Nextflow, you should definitely try it. So the idea of this training portal was to have DSL2 content, high quality, centralized, and it's on GitHub, so everyone can contribute. And that's the best thing about it. People have contributed to it. So the Spanish was all volunteers, the French one, the Portuguese one, there were a lot of contributions, and the English, of course, people are always contributing. So if you run into something in the training material and you think it could be better, open a PR. It's going to be more than welcome. Talking to you about localized content, we had this idea in this March hackathon this year to have the trainings we always do, but in different languages. And so we recorded, like Chris Hackard did the one in English, I did the one in Portuguese, Maxime did the one in French, Julia and I think Giselle, I'm sorry, I don't remember, I think it was Giselle did the Spanish one, and Abhinav did the one in Hindi. So the feedback was amazing. People were really happy about it. We have a large number of views in all these videos. And even if, as we are always creating new content, you have this relatively up-to-date content in all these 5 languages. And it's been very helpful for people. We also had this thing that community is growing so fast. We have so many new things, new individuals, new features, new pipelines. And if you're not like every day in the community really contributing, it's very easy to miss things. And we wanted to have a place where we could talk to people and show these key players in the community, these new features, these new events, new blog posts. Like, I'm just joining the community, I'm a bit lost. Where can I go and see this informal conversation about these amazing things that are happening very often in the community? And that's what Channels is about, the Nextflow podcast. So the mentorship was already going on the first round, as I said. We had the second round, which again was very nice. And recently we just ended the third round. So all these rounds, they were different in a geographical way. Like the first one, we had most people from Africa and Asia. The second one was a bit of a mix. And the third one is, as you can see here. So our goal was to make sure the mentees are in underrepresented regions. So it was mostly like Latin America and the Caribbean, Africa, Oceania, a bit of Asia. So that's been our goal. We always have had over 50% of women being part of the mentees. And in the mentors, we also try to do that also. So it's been a great experience, lots of people learning. And the best thing is that it's a very good way to have people interact more in the community. So a lot of mentees, they would start with a project, and during the project, they would contribute an NF Core module. They would contribute with translation. And eventually, some of them became Nextflow ambassadors, which is the program that you heard a few days ago. So this has been a great program to increase the geographical reach of Nextflow, to create nice content, because as they are learning, they are also contributing, and we have many more NF Core modules and pipelines and all these things now. The ambassador program was the great answer we had for supporting the community. The community was already amazing. A lot of people were doing great work, and we wanted to make sure they feel recognized and we can support them and keep doing great work. Most of the ambassadors that were reached, invite them to be part of the program. We didn't have to ask them to do anything more. We just said, can you keep doing the great work you've been doing for all these years? And they happily accepted. So this is the Nextflow Ambassador Program. I won't get into detail because you already heard about it, but feel free to go to the nextflow.io website if you want to know more details. But that's the main and current answer we have to provide support for these people that have been for a long time doing great work for Nextflow and NF Core. We had also this great idea in March to do this local hackathon sites. So it was hybrid, like it was in the past, but now you could organize local sites for your local community, in geographical community, right? In your geographical area. So Sequeira supported this, paying pizza and stuff, and here you have some of the pictures of some places where it occurred. So we had, like, in all the continents, we had someone doing a local hackathon site. It was a great experience, very, very nice. And again, we see these activities making people more integrated into the community. Well, all these things that I'm telling you, things that I saw could be better, things we've been doing to make it better, all this experience I had. I've been for a long time also in the past year, like just traveling in, giving talks, and spreading the word about Nextflow, mostly in Latin America and the Caribbean, and I've seen clearly an effect of that. So like next month, there's going to be an event in Chile. I got invited to give a talk. I won't be able to attend, but now we have people in Latin America who can do that. We have people being giving trainings, people writing NF Core modules and pipelines, and people who, a few months ago, they didn't know anything about Nextflow. So all this support we've been doing on Latin America and the Caribbean, which is a region I can speak more about, we have clearly seen this benefit and people participating more in the community and contributing back, which is great. So just some numbers about this growth in the past 1 year, with like 20 invited talks in multiple countries. If you take into consideration talks from other people in the team, like Phil and Chris, then it's a much larger number. We started this initiative to have a graduate course on Nextflow. So we got in touch, it was the first demo, we got in touch with a university, and we want them to create a course for master and PhD students to learn Nextflow and get credits for that. And after that, Sequeira would certify these students. So it happened once in Brazil, it was a success, and now we want to expand. So if you think in your university there's interest about it, reach out and we will be more than happy to try to do that, make it happen. Multiple training sessions and demos. So the training sessions we recorded in the past 12 months have over 20,000 views on YouTube right now, which is great. And we had almost 3,000 registered participants in all these training sessions from October until today. So that's it. Thank you again The community is amazing, and I'm really happy to be part of it. And I hope that you guys keep being involved, and that's it. Thank you very much.
Thank you, Marcel. It is a really cool job, isn't it? All right, we have a few questions in Slack, but we're out of time. So if you can join the Slack in the spirit of, online community and all of that.
Thank you again.
Thank you so much for the talk. And now we're going to continue with Ram Prasad, who is going to talk to us about a disease for analyzing data from, a workflow for analyzing data from patients with rare diseases. Thank you so much.
Yeah, no one should be like me and send the presentation last minute, because this is what happens. So, let's see. Yes. Okay. I'm Ram Prasad. I am a bioinformatician at Clinical Genomics in Stockholm. And I work in a team that works closely with the local hospitals to try and develop pipelines for diagnostic needs. This might actually seem like somewhat of an innocent statement to make, but there is a big problem in what I just said. The problem is one of fragmentation, right? Often hospitals work with units that are sort of work closely with specific units, and you have this happening at different places, which means that people just start to work in silos, right? So for example, if you look at Sweden, so in Sweden we have 21 regions, and these 21 regions are responsible for their own healthcare, and being responsible for their own healthcare means they establish the same units at multiple different places doing the same thing. And and over time, people just start to sort of reinvent the wheel, do their own thing, and that leads to a situation where there is very little knowledge transfer between the groups. And they also, especially if you look at computational biology side of the healthcare, people often just end up writing pipelines that are very specific to their local needs, and but with the same aim. So, for example, if you can have multiple units working on rare disease diagnostics, but then you end up in a situation where you just have multiple pipelines all doing the same thing, but very specific to the local infrastructure. So this means portability also becomes an issue. So it's just hard to find people to collaborate with. So so this is, in Sweden, we realized that this was an issue. So different hospitals and regions sort of came together to start Genomic Medicine Sweden, which is sort of an initiative between several partnering regions and the hospitals. And it was and the goal is to sort of bring genomic, translate bring genomic diagnosis into clinical practice. Under this GMS organization, we have 7 different participating units, as you can see in the map here, and I sit at the GMC Karolinska. one of the goals of GMS is to sort of establish national standard pipelines for different disease groups. So for example, I mean, we want to establish one pipeline for rare disease diagnostics, one for cancer, and one for metagenomics and things like that. For, you know, I mean, if you're starting to sort of think about making something that can be established as a national standard, I mean, it has to be something that's easy to collaborate with, because different units have to be able to contribute to it. And to sort of like, to help them collaborate, you need the pipeline to be sort of agnostic to the computing infrastructure that it is being run on. So of course, like we decided to sort of, you know, develop the pipeline in C. No, just kidding. So of course, like we ended up doing it with Nextflow. And one of the benefits of us choosing Nextflow over other workflow managers is the support from NF Core community. The initial days, I mean, of course, you know, like I sit in Stockholm, where Phil, Maxime, and several other Nextflow or NF Core co-group sits. So we've had several discussions, and in the end, we decided to sort of like start developing in Nextflow. So that's kind of how NF Core Rare Disease began. And if you're starting to develop a pipeline and trying to work with multiple groups, you need to start somewhere. So we decided to use a pipeline that we are running in production in Stockholm region to diagnose patients as a template. And the plan was to add features that were different, but were being used by other units on top of the template, and sort of like build something that's, that incorporated things that all the units were doing, and sort of like keep it very customizable so different units can choose you know, how they want to run this pipeline. So if you guys want to know more about the template pipeline that we use, you can find it at this GitHub repo, and there's also a paper that was published 2 years ago, which should help you, yeah, I mean, in case if you want to know more about the pipeline. So it's, you know, it's been a 2-year journey, and this is what the pipeline looks like today. I mean, yeah, we've seen several iterations of like metro maps for different pipelines, so you guys are very familiar with how this, you know, how to read this image. So the pipeline, so the way we sort of like thought about this pipeline is to sort of have, you know, sort of different units that you would typically see in a rare disease pipeline. And sort of keep it in a very sort of a customizable way. So for example, of course, it's very typical to do a pre-processing, and you do the alignment. And in alignment, we had this challenge because we had one unit that was using Centayon, and we were using BWA. So then we sort of like kept it at customizable, so people can run Centayon if they want, if they have the license to run it. And then, of course, Centayon also has a variant caller, which the other units were using, but we were using deep variant, so we needed to be able to sort of incorporate that difference. So we added that feature as well. But the way we have sort of written this pipeline, if at some point the unit that's running deep variant wants to run Centayon as an aligner, they can still do that. So they can use a Centayon as an aligner and run deep variant. So we've tried to sort of keep the pipeline very modular. And the pipeline also has several other features. So of course I mentioned pre-processing, alignment, and variant calling. So there is also a structural variant calling, and we have CNV callers. We also have a separate mitochondrial workflow, which, because, you know, of course it's somewhat different because you typically have very high read depth, so we had to have something separate that sort of accounted for those differences, so we incorporated GATK's mitochondrial sub-workflow. You know, I mean, it's one thing to get all the variants, but then you also need to be able to annotate it. So we also have several annotation workflow that annotates SNVs, SVs, mitochondrial variants, and of course you also need you get QC metrics as well from the pipeline. Right. And at the moment, yeah, the pipeline can handle whole genome sequencing data, whole exome sequencing data, and the whole exome sequencing data. It should also work with panels. We haven't tested it, but I mean, there is nothing in the pipeline that shouldn't or that doesn't support the panel data. So it should work with panel data as well. And because this is a rare disease pipeline, you also need to be able to sort of handle, like families with different dynamics. So trios, single sample, and whatnot. So, and the pipeline is written in a way that it should be able to handle it. I invite you all to sort of like test and see if you can break it. And if you can break it, please let us know and we'll try and fix it. Because that shouldn't be happening. So what is in the future? The plan is to add several more features. So we lack mobile element insertion and corresponding annotation at the moment, so we want to add that. We also want to add some support for Dragon, and there was some progress during the hackathon on this front. I think we have a sort of a base Dragon module, and then of course modules repository in a PR. And the future is in long reads, so we also want to be able to support long reads at some point. And of course, like we want to be able to, as you saw, I mean, there are several parts to this pipeline, and it would be great if we can sort of like bring enough tests to sort of customize and like test and be able to test the pipeline as we develop it. And one feature that we don't have, but we would like to have is multiple entry points, which Frederica was talking about for SAREC. So we want to be able to do the same thing with rare disease. So people can sort of choose what parts of the pipeline they want to run and just be able to run that specific part. And we also want to be able to optimize it. At the moment, we only do scatter gathering at the annotation stage. We want to be able to see how useful it can be during annotation and other stages of the pipeline. So that's kind of where the future is for the rare disease pipeline, I see. And that was more about the pipeline, but since this being an Nextflow Summit, I also want to sort of talk about a feature that I really like about Nextflow. Like most of you guys will be able to sort of understand like what's going on in that slide, right? I mean, it's just a sort of simple retry strategy where if a process fails because of certain error codes, then try it again with like more memory or more CPU. And the reason I like this feature, and other developers in my team like this feature, is that we work with hospitals, and we also work for a university, which means we have to be very conservative about like the costs. So we can't go crazy about with our computing infrastructure, but at the same time we have to be able to reduce the turnaround times for the samples so that we are able to get the reports to physicians as soon as possible. And often, like, we would run into situations where a process fails because because there was not enough memory or like not enough maybe it went over the time limits on the cluster or whatever. The issue we've had, or we still continue to have because it's not in production, is that in production, like pipelines would start analyzing a sample, and they would sort of fail because there is not enough memory, and then someone will have to like go in manually and fix it, or like start a rerun with more memory to sort of run to get the sample to run to completion. This is a big problem for us because, if you have a sample that fails on a Friday, no one, you kind of have to like wait until someone comes in on Monday and restart it, which means that we've sort of like lost 2 days in the process. And this also means that we have resources that are just like doing things manually, which we could otherwise automate. So we are very excited to sort of like have this feature in production because this would mean like our production team will be spending less time doing this, and more time maybe, like working on other features that could be useful to have in the production. And for patients, of course, this means they get a diagnosis faster than they otherwise would. One of my colleagues, Jesper, recently said that teamwork is dream work, and in that spirit, I would like to thank all the people that have contributed to the pipeline, and and also the NF Core community. They've been very, very helpful in the past 2 years, especially like people like Maxime, who was willing to sit down and have several meetings with me, and he let me pick his brain. Thanks to all those people. And sorry, I didn't know there was. And also, I would like to thank GMS and SciLife Lab for supporting this. Yeah, that's it.
Thank you so much. Great talk. There's again a number of questions in Slack. We're out of time to ask them to you right now, but a lot around the flexibility and versatility of the pipeline. I think there's a lot of interest. Thank you. And so next, and the last speaker of this session, Manasa, is going to tell us about enabling bioinformatics at AstraZeneca with Nextflow. Please, thank you.
Hola. Thanks to Barcelona and Sekira folks for giving me a warm welcome this week. And I'm Manasa Surukala. I'm product lead in the R&D IT Omics platform at AstraZeneca. So before becoming a product lead, I was a biologist and a bioinformatician, and have been working with AstraZeneca because I love being closer to science and also contributing to society, and hence AstraZeneca. So at AstraZeneca, we focus on several therapy areas, and we have both research and development, which has several stages before medicine reaches to patients. And I am more focused on the target discovery, preclinical, and clinical phases. Wearing my biologist hat, I have come across really complex, large volume, and high throughput data on different modalities coming in and out through these stages. And for a scientist or a bioinformatician to look at this data, we need workflows that scale, run fast, and also in a compliant environment. So I have a quick question for the audience here. In the context of workflows, how many of you are runners? Sorry, it's pretty hard to look from here. It's blinding. Given that the number of attendees are increasing at these conferences, how about a summit at the beach? Just kidding, giving an idea there. And how many of you are actually builders? Yeah, I could see more ratio of runners to builders, and being in biologist's shoes, I have been a runner myself, and I have started my journey to becoming a builder, and then I hit this. I'm sure many of you have seen this. Frustrating, isn't it? This is where Nextflow and the community has really helped biologists like me to kickstart off my journey. So thanks to Sekira and the community for being there for biologists like us. So let me give you a quick glimpse on the kind of journey that we started with Nextflow. 4 years ago, we had this joint venture called Functional Genomics Center, which is a partnership between AstraZeneca and Cancer Research UK. And we have CRISPR technology, state-of-the-art facility there. And it's just right across our new building called The Desk in Cambridge. And I've been there last week for the first time, and I can vouch that I can literally see the Functional Genomics Center from there. So what do we have? At Functional Genomics Center, we have both the scientists from AstraZeneca and CRUK putting forth several CRISPR screen proposals. And depending on the kind of project, the data actually flows through either AstraZeneca or CRUK. And we collate the metadata at sample, project, and library level. You should really appreciate the fact, despite the data flowing through two different organizations, we still fundamentally have the same CRISPR pipeline in Nextflow and enable the scientists and bioinformaticians across these two organizations to commit their codes and collaborate. But at the same time, we create private modules so that it caters the needs of different organizations. Now, let me give you a quick glimpse on what we have done this year at AstraZeneca for the CRISPR project. So when a bioinformatician actually has the metadata and decides, okay, the CRISPR screens are good, this is the cohort I want to go ahead with, they can actually auto-launch whenever the data is ready. So let's say the FASTQ files are ready over the weekend, it can automatically kick off and be ready for a scientist bioinformatician to look at the data. But at the same time, imagine with the current CRISPR cohort, they want to add the old cohort or old samples from there and analyze the data. In that case, we have provisioned a manual launch so that the scientist or bioinformatician can go into Nextflow Tower, Secura platform. We'll try to get used to that. And then they can kick it off. But at the same time, they would be able to look at the Secura platform and understand what's the process workflow looking like, what is the run at, and monitor it. But at the same time, we enabled automatic notifications to their teams. The bioinformatician's happiness index increased after that. So the results from these screens are enabled and available through database, and this data product is available for bioinformaticians to look at the high-resistant genes across projects. But also, we have other user groups, such as data scientists and analysts, who look at knowledge graphs, design ML and AI models to enable novel target discovery. So through this journey, via automation, we have rapidly reduced the end-to-end workflow time, but also given the flexibility to the bioinformatician to either manually launch or automatically launch them. So this has been a really successful project with Nextflow and Secura platform, and it has enabled us to think about where we are with the platform. So if you see the Nextflow Tower, we have enabled the bioinformaticians to take a quick glance on what the configuration looks like, and also the key steps in the pipeline, which actually hides all the code behind it, which is very appealing to a biologist like me. And also enable looking at the key metrics from the pipeline, such as the runtime and also the cost of a run, which usually takes hours to dig into the log files in the old way. Not only that, on the platform, we would be able to see the high-intensive compute steps, which enables the engineers and the bioinformaticians to continually optimize our pipelines. So keeping all the positive things aside, what if a run fails? In the olden days, we used to go into the log files, take hours to understand where it actually failed. But through the platform, we are able to quickly take a glance at where it failed and how can we fix it, but also relaunch at a single click. So that has been a very successful project with CRISPR. Now, putting on my product lead hat, in the omics platform, we aim to provide the scientists with rich omics data ecosystem by giving them repeatable analytic pipelines, fair services, and data products that are very well integrated so that they can work with analytics-ready data. So last year, we have been rethinking how we can structure the platform and came up with these several layers of capabilities that can actually look at adopting and being flexible at accommodating CRISPR, DNA-seq, RNA-seq proteomics, but also are scalable enough to adopt any new technology that comes in. So in the orchestration layer is where we have Nextflow and Secura platform. And we have started looking at transforming from project level to a capability level so that we can provide different workspaces to different user groups in AstraZeneca. Not only that, we have given standard, industry standard RNA-seq sort of pipelines for user groups to work with as a self-service, but at the same time, given them the capability with infrastructure, storage, everything intact with the workspaces so that they can quickly deploy customized pipelines as needed. Not only that, using the cloudability, the AWS tags, we have been giving them reports around what is the cost around the compute and as well as storage whenever they are running the pipelines. So by doing all this, we are trying to speed up the front line of delivering data to our scientists and bioinformaticians, thereby helps us to deliver medicines to patients faster. So all this journey wouldn't have been possible without the great effort from our teams, both in R&D, IT-omics platform, and oncology, and also not without the great support we received from Secura folks. And Surya, Salim, and Russell, who couldn't be here with me today, but they have been driving this immensely on the capabilities. Also, we are hiring in Barcelona. It's just 20 minutes away from here. So keep an eye on the workplace and let us know. Thank you.
Thank you for a very engaging talk, and that's a really cool setup. There is a question on Slack. Did you encounter any particular challenges to incorporate Secura platform into your workflow? And here I think we're talking about workflow as in process.
Yes, we had to internalize the Nextflow tower, and we have been given the Docker through the Secura folks, and they have been immensely helpful to internalize and expand our user base in the AstraZeneca as well. So kudos to that.
Excellent. One other question, just from the point of view of community. So you have user groups and that you're trying to enable. Does that tie at all into NF-Core and the Nextflow community? Like, is there some overlap? Are there things that you find you can organize at that level?
Yes, so we have been conducting a lot of Nextflow trainings through you, obviously. And at the same time, we are starting to build Nextflow community within AstraZeneca as well. And we are looking to partner with Secura folks to have at least 1 or 2 people embedded and see how it goes. So it's a transformative journey, and we are looking to grow more.
Wonderful. Thank you so much.
Thank you.
All right, so now we're going to take a quick coffee break for 30 minutes, and we'll see you all back here at 12. Thank you.
Oh baby, I wanted you to be here inside my arms where the night goes down. Oh baby, I wanted you to be here when the sun comes up and the day goes by.
All right, everyone. Thank you for coming back for our final session of this morning and also final session of the summit. We have 5 talks left. They're all going to be great talks, so thank you for coming back. And without further ado, I am delighted to call up to the stage Phil, who is going to talk to us about multi-QC.
Hi everyone, nice to be here again. I've got something a little bit different for you all today. It's one of maybe the first ever talks at a Nextflow summit not to be directly about something Nextflow related. It does tie in, so bear with me. I've got just a short talk today to kind of go over multi-QC, which is one of these other tools I've had the pleasure of developing, and talk a little bit about some recent things that have come out in recent versions and some of the directions that we're now taking with multi-QC and what you can expect in the future. So for anyone in the audience or watching online who's not familiar with multi-QC, it's a generalized tool for working with, it can be any kind of data, but historically mostly genomics data, DNA sequencing, and it's really good at aggregating results across multiple samples and tools into a single report. So in kind of pictorial format, if you go to the multi-QC documentation, you'll see this diagram where you can imagine you've run your Nextflow pipeline, and maybe if it's RNA-seq, it's got like 50 different bioinformatics tools that ran, and maybe you ran with 150 samples. And so then you have all these log outputs, which are all different file formats. Some of them might be nice, well-formatted YAML or JSON files. Many of them will just be standard out with weird formatting, which are kind of designed for people to look at. But when you have thousands of them, it's not very practical. And multi-QC is really good at understanding, finding these files and understanding all these different formats, and then summarizing that and distilling it, pulling out just the really important bits to show you in a nice HTML file, which you can kind of scan through, and it's not going to go all the way into the depths of your detailed analysis, but it will hopefully highlight any samples which might be problematic and give you a good feel for how your project went. I was explaining this to someone the other night, and any Hitchhiker's Guide to the Galaxy fans will recognize this. I said it's a bit like a Babel fish. You have this kind of mumble-jumble of all these different languages from all these different bioinformatics tools coming in one end, and it spits out a nice standardized data files also for downstream analysis, and a nice kind of understandable, human-readable report. So, multi-QC, you know by now. I like the numbers. I like to give some context. How many different tools? As of right now, there are 135 different bioinformatics tools which are officially supported. And that means you can just throw those files at multi-QC. Multi-QC, just give it a directory to search through, and it will find those files and understand them and generate a report with them. There's probably many more unofficially because you can format your data in a way that multi-QC understands, and it will pull them in. And you can also have custom modules which you install, and it ties into the multi-QC runtime. But these are the kind of core different tools which are supported by multi-QC, and it's growing all the time. Been very fortunate that multi-QC is not a complicated tool. At the end of the day, it's mostly just a lot of regular expressions and an HTML template. But it hit a niche, and it's become very popular, and which is lovely to see. It's also quite terrifying. And we hit a nice mark the other day where we went past 1 million downloads on the Python package index. Thank you. And of course, this doesn't take into consideration Bioconda, which is still trying to figure out how to understand those numbers, and like Docker and everything else. So it's a huge number of people using PyPI, and we also hit another milestone, which was 1,000 stars on GitHub. So thank you to everyone here who's hit that little star button. Show some love. And just for some context, someone runs multi-QC roughly once a second. No pressure. So what's new? The big news, we put out a blog post about this the other month, is that it's no longer just me. I mean, we've had a big community behind MultiQC. Most of those 135 modules were not written by me, they were contributed. But at the core tool of maintenance has always been me for the past 8 years. But I'm very happy that we managed to hire the number 2 contributor on the GitHub page. It was easy to find him. Vlad has joined Secura and is now working full-time on MultiQC with me, which is brilliant to sort of share, well, I say share, he's really now doing all the maintenance, and work on MultiQC together. And I mean, it was always going to be an obvious pick because Vlad's been working on MultiQC for years, but really just to hammer it home, after I spoke to him in an interview, he put in a pull request for next week and managed to speed up the file search by 720%. So yeah, it's pretty tough to beat that, really. So if you pulled MultiQC version, I think 1.15 or later, and especially if you have a lot of files to run on, MultiQC is significantly faster. So that's the kind of stuff we're starting to pull in now. Something else, I mean, I said now MultiQC is very popular and it's phenomenally well cited in the scientific literature. It has over 4,000 citations, which is ridiculous. And it's kind of a fun little hobby to kind of go through and see all the different kinds of things that people are using MultiQC for. And it's such a wide range. You know, NASA's running it on the International Space Station and is, of course, involved in COVID and involved in pretty much anything you can imagine, really. It covers the full breadth of bioinformatics and beyond. And I always feel kind of a bit guilty because MultiQC is visible to the people running it. It sits at the end of the pipeline, and it summarizes all these results from these amazing bioinformatics tools. And I think probably people notice MultiQC because it's the thing they see, and maybe don't always kind of see these amazing bioinformatics tools in the background, which actually generated the data and did the hard work. So something I did to MultiQC earlier this year is now all of the MultiQC modules, all 135 of them where possible, include a DOI in the MultiQC code. And so now in the MultiQC report, alongside those results, we include little hyperlinks DOI to the reference for that tool. And MultiQC also generates a citations file every time you run it. So to hopefully encourage and kind of pass on the love to all the other scientists, many of you probably sat here, doing the work that feeds into MultiQC. Something else that is really important with reproducible research, of course, and something we've worked a lot with in Nextflow and within the NF Core community is reporting on the version of the software that is being run. And it's been sort of in the back of my head for years. Actually, there's a stub pull request that was from, I think, 2016 from SciLife Lab that Ricard said. He started and said, I'm going on holiday for a couple of weeks. I'll put this here just in case anyone else wants to finish up. And it's sat there ever since. But it has sort of been in the back of my mind that the logs, many of the logs that are read by MultiQC include version information. And so Pontus Hoyer, who put in a huge effort from the community, which is amazing, and has added support, again, to all 135 different modules where possible. And now all of the MultiQC modules where that information is available will parse it, add it into the report in a standardized format, and again, it will show up alongside. So it's really, really easy to know what ran in the analysis. In MultiQC, in NF Core, we also like to group the version numbers by process. So one process can have multiple tools, and also, in theory, a single tool can run multiple times with different versions. So we've also added support for grouping versions and producing these files. And there's quite a lot of work in the NF Core hackathon earlier this week to adopt this new format of version reporting, so we can cut out a lot of the boilerplate code in NF Core pipelines. So, little feature, but it's the little features that sort of add up over time. Okay, that was just a couple of highlights from kind of the last few months. What kind of stuff are we going to start doing now that we're growing the MultiQC team, and what can we look forward to? probably the first thing we're focused on is thinking about the multi-QC reports themselves, the front end, which has really been pretty much untouched in many years. So I'm really glad to making excellent progress on this already, switching out the underlying plotting library, which we use, to Plotly. And one of the great things for this is that this opens us up to having many more plot types. People have been asking me for box plots for years, and it should now hopefully be possible, and things like clustered dendrograms onto heat maps, and lots of things like this. Plotly is a very expansive and powerful plotting library. And the other thing is, if you run multi-QC with really lots of samples, and the HTML will be so big it would crash your browser, multi-QC kind of automatically switches modes and creates a static PNG image. And that's done with matplotlib at the moment. And for every plot in high charts, I've had to manually write the matplotlib code to try and make a plot that looks the same, which is another reason I'm not keen to add lots of different plot types. And Plotly is great because Plotly, you can just like say, flick a switch and it has all that built into a plotting library, so we don't have to do that anymore. So that will hopefully be coming soon to a new version of multi-QC. Along with that, that's going to basically break a lot of stuff in the template for multi-QC. So we're going to take that opportunity to have a dig into the HTML and see if we can implement a few features. Some of you will be pleased to know that dark mode will hopefully be coming to multi-QC. Especially relevant at today's screen. You no longer have to wear your sunglasses to see multi-QC. So some little things like that will hopefully make it a bit nicer to work with. Anyone who frequents the multi-QC website might find I really like dark mode. And a little Easter egg tucked away in there if you click around enough times. Triple click. We're also going to really get into the weeds with the core code and come back and look at how the original library was structured back in 2000 and whatever it was. Finish porting from Python 2 to 3 and all of the best practices that come with that. Things like code typing. I'm going to start using MyPy. Better use of kind of objects and classes and really amazing libraries like Pydantic, which have come out in recent years, which allow us to have real richly structured data objects within the multi-QC runtime, and we can leverage lots of things from this, validation and all kinds of things. Part of this is also going to be really useful for anyone running Python scripts and being able to use multi-QC not just as a command line tool, but also as a Python library. So Evan's wonderful demo of Data Studios with a Python notebook, but the hope is you'll be able to import multi-QC and then run some parsing, inject some custom stuff, tweak this, tweak that, have a specific plot, and really access all of the powerful functionality within the Python code used within multi-QC. So look forward to that soon. And one of the reasons for using Pydantic is we also hope to leverage some of the interoperability that gives us with different file formats. We want to, when you run multi-QC, it searches files, it passes all the data, and then it generates a report. And it kind of does that in a linear fashion. And we want to introduce a standardized file format in between parsing and report generation. This will mean that if you've run multi-QC 6 times, you can go back to those intermediate files and generate a report that combines those reports, which people ask me for a lot and isn't possible currently. It also means you should be able to do things like have multi-CPU parallelization and a bunch of other features. And by using standardized file formats like Apache Parquet, I hope many of you are kind of building custom solutions with data lakes and things like this. And it should really be able to kind of enrich the ecosystem that builds on top of the work that multi-QC is doing. Okay, I've got a couple of minutes left. This was like a nighttime bit of fun project, and everyone else has been doing live demos, and I can't miss out, so I'm going to try a little live demo. One of the technologies that's kind of been around just recently and has got a lot of hype is called WebAssembly. It's kind of like basically running a VM virtual machine inside your web browser. So you can all follow along with me if you like. Do this on your laptops or whatever at the same time, see if you can get it to work. multiqc.info/run. Now, You can click down some example data just here, or you can use some data you've got kicking around. Just load that up. And then got a little drag box. This only works on Chrome, basically, at the moment, and Opera, I think. So there's room for improvement. I'm going to drag these data files on there. And these have now been mounted into the WebAssembly VM, I'm going to call it. It's not, but inside the browser. And in fact, if I look at the browser config console, you can see when the page loaded, it's loaded micropip. So this is using, I forgot the name of it now, the Python WebAssembly library, and it's installed micropip, and it's installed multi-QC inside here. I don't have multi-QC installed locally. This is not using my terminal or anything. This is just within the web browser. And I've added my files, and I'm going to click run. And because it's too fun not to, I've made it look like I'm running in a terminal, but it's not really. And then I can click open report. So, like I say, this is a bit of fun. Like this multi-QC still lives at the end of pipelines, but yeah, maybe there's some users out there who get emailed an email full of fast QC reports, and now if you're one of these people who's like terrified of a terminal, now you can just load up a web page and click around. So, bit of fun. I can resist. That's it. Short one today.
Very cool demo. And all the improvements. It's been observed that there's probably a lot of tips and tricks that live only in your head, maybe Vlad's now.
A lot of what?
Tips, tricks, specialized knowledge, edge cases and all sorts of things like that. I think the first recommendation, and you and Vlad don't get on a plane together. The first one. The second one, there's a lot of demand, I think, for training about that sort of thing.
Yeah.
We need to move on. I'm sorry we're out of time, but that was very cool. And please get on Slack because there are additional questions. I feel kind of bad kicking Phil off the stage. It's like, oops, can I do that? But I do want to welcome Edmund, who is going to talk about getting NF test into NF Core, and that is a very important topic. So thank you.
All right, hello everybody. I'm Edmund Miller. I'm from the University of Texas at Dallas. And today I'm going to talk about testing, in case you all haven't heard enough about it at the summit here. All these lovely people as well here also were a part of starting to test NF test, or testing with NF test in NF Core. That's not going to be fun. Left and right. All right, there we go. Lovely. So why does everyone keep talking about testing? So testing data pipelines is really hard, is what we found. We really just want the bare minimum. We want confidence in our results. We want to make sure that things stay the same between versions. And we've also found that bioinformatics software is really finicky. So in the original Nextflow paper, there was a figure, in case y'all haven't read it, that's talking about the reproducibility and the difference between software versions, and basically how even just using different, like using Mac OS versus Linux, you get completely different results from your data. So that's what we're trying to avoid here. We're trying to test between Singularity, Docker, Conda, all the things. Make sure that that is reproducible. So a little history of testing at NF Core. I kind of went back here, and this was really fun. So I found the first commit that had CI. May 11th, 2017, Phil added automated test via Travis. This is also about the time that I got into bioinformatics. In October 7th, 2019, they started using GitHub Actions. This was also before my time in NF Core. and it came out in the template in version 1.7. November 24th, 2020, Harshal made a very poor decision to merge a PR that I had to add PyTest workflow to NF Core modules and opened up Pandora's box here. And then in May 19th, 2021, I'd been playing around with testing my workflows with PyTest workflow and CI. Maxime found that, he ran with it, and it's grown into a whole thing. And then lastly, I guess that's not gonna work that way, so we'll just scroll down. So October 10th, last hackathon, Nicholas brought us into the modern era with NF-test and added the first PR for that. So this is kind of what PyTest workflow looked like. It was kind of a mess. As you can see, we have these like workflow stubs, and all we're doing is just trying to fit some input into FastQC here. It's kind of scary, not very new person friendly. And then we get these YAMLs, and these YAMLs then have lines of code that you can just run a bash script on for Nextflow run. And basically, we're just calling Nextflow run, and then we're adding some tags, calling these various files on these. And then we're just checking for the output and the contains of that. So, and then lastly, we can also finally check for the MD5 sums as well, which is really important to make sure that the files stay the same between version releases. So, some things that we learned along the way. Basically, checking what code and only running tests for that code is one thing. I think we're really going to have to pay for our sins here when we get the CO2 plugin added as well, and answer for some of that. And so then we also had, we also needed to up the speed of this as well, of everybody sitting around waiting for pipelines to run and all that stuff. And then we also learned that Conda hates checksums. It just never matches up. And then lastly, the investing time in this actually pays off in the long run. It is a slight more investment in time, but then we end up having more, we fix less bugs in the future. So a couple NF-test features that we love. I'm not going to recover all of that. So first thing, simple one-line install. It's fantastic for new people. You just get up and running with NF-test. If you can install Nextflow, you can install NF-test. Next, it has some native support for Nextflow things, such as profiles, which is great. Instead of running all these PyTest workflow things and the convoluted stuff that we had going in CI that was just a mess to maintain and explain to people, and new users were like, they just didn't have any idea what was going on. And so then we also wanted to test everything all the way down. So we could test the processes, the workflows, the pipelines, and then even the functions as well. And so that was kind of revolutionary. And you'll notice also in this slide that there's a generate function that's happening as well, and that's because they're generating the test for you. And then, of course, snapshot generation that we talked about yesterday. We all love this. It's great. I used to go through and manually add the MD5 sums myself, and then we wrote a whole bunch of tools to like pull those in and rewrite them. I think Kevin did that a while ago. But now it just kind of automatically happens. Great idea. And then you can just run update snapshot whenever you update your software. And then another thing that's always a pain is in bioinformatics, we use so many like gzip files, and how do you test the contents of that? And we could write convoluted custom things for PyTest workflow, but you can just use Groovy here in NF-test, and so that's really powerful. And I've seen a lot of cool things happen at the hackathon with that. And then there's also just some plugins that we can start adding. So far, there's Fastas, and you can kind of see that we can do various sequences, check for things. Again, making sure that our scientific results are accurate. So let's talk about adding NF-test to NF-test modules. So we wanted to only run the CI on code that changes, and then we also want to split up these jobs to run it on separate runners as well. And I apologize in advance. I gave a bite-sized talk about a year ago on NF-test, and I realized I got to the end and I had no memes in it. So if I overcompensate here, I'm sorry. So modules has a ton of activity. Has like, for example, it's got 36,000 workflow runs going. This was about a month ago, but I checked again this morning and it still had 36,000. So in a normal month of activity, we typically have 68 pull requests closed, 17 opened. This was pre-hackathon as well, so like not even including the hackathon here. So tons of activity, lots of stuff to maintain, a lot of stability issues. So I was trying to convince Harshal and like that we needed to switch to NF test. And he kept telling me, dude, I just don't know how to make it happen. Like we can't convert all of them at once, and Satish came up with a PR to, do it automatically. And I said, ¿por qué no los dos? One night. And I realized, why didn't we just run them both in CI and give the optionality to the users? So that's what we did. This is Adam's workflow that he ended up writing, and I just kind of wrote a rough draft on the first one. So now it'll run PyTest workflow. There's PyTest workflows there, or if it picks up NF test, it'll run NF test. You can run both at the same time. It doesn't matter. So we're slowly migrating those over, and that's what a major effort of the hackathon was for. And then as you can see, we also run that. So before the hackathon, we tested FastQC, which was my proof of concept, and then I think Adam added a test for SnakeMake. Don't know what to think about that. So we were still supporting PyTest workflow, and we still are. And then, so we're only running the test on the changed code, which was a big thing as well, because we don't want to run extra tests. Now, we have 59 modules and sub-workflows tested. Thank you to the community. Hopefully in the coming weeks, we'll get even more of those. We've also added automated module maintainers. I'm sorry for everyone that got pinged yesterday for 100 reviewers on various things. And then in the future, we're going to have automated version updates coming into the packages as well. So then the tests will get run. If they auto-pass, it'll just automatically update the version for everybody. So let's talk about NF test in pipelines as well. So quick introduction to NF core if you've never heard of it. So it's Nextflow pipelines with a twist. They run on everything. That has a lot of issues surrounding it and then trying to run on all these platforms, making sure that they all work. Then we also have to support template updates. And when those templates come in, you cut a new release typically, and they add new features. However, those new features come with unintended bugs. And so also you get pull requests in from the community as well. And that's another various issue of things coming in when you're supporting an NF core pipeline. But how do we have confidence in this code from new contributors that are around the world? So that's kind of what we're trying to solve with all the various testing aspects and why we're so heavily focused on CI. So in MethelSeq in 2.4, we first added NF test. That was the first pipeline. We felt that was symbolic since it was the first NF core pipeline. And then, so pre-hackathon, we had gotten through 7 pipelines. Post-hackathon, we have gotten through 11 with a couple of PRs open for some more. So this is kind of a little project I've been working on as well. So we have these various runners, and we've kind of realized that they're a finite resource, and it's difficult for when you're waiting in line, essentially, for them. So what happens on these runners, and you can really see this in Seric, basically you run each of the tests in sequence, so you're running multiple Nextflow workflows one after each other, so it'll take 20, 30 minutes. And so as you can see, like 16,000 workflow runs in a month or so on Seric. And then we get community feedback from it, of course. In case you're not in the NF Core meme Slack. Had to give credit to those. So I asked for a NF test feature. And of course, they're great. And so basically we had, typically these software tests are ran in parallel. You're running like 1 + 2 = 3. Usually these tests don't take 5 minutes each as well. So let's think GitHub Actions for batch. So basically, instead of listing this, we list it in a JSON. That lets us then pull it into GitHub Actions, and then we can split it up, and we can run each of these on a separate GitHub runner. And so that will significantly speed up the testing time to 5 minutes of a CI check versus an hour. So where are we going? Hopefully we're going to lock down the NF Core NF test standard and get that kind of locked down so people can actually adopt it instead of trying to keep up with Harshal on those and his team. And then we're going to add NF test to the template. And then lastly, we'll swap out the test generation so when you create a new module, you're not rewriting the PyTest workflow tests. So, in conclusion, this is from James. NF test all the things.
All right, awesome. Fantastic effort. I look forward to having NF tests for everything, right? One quick question. Can I execute NF test using the parameter file as input? For instance, if I run my Nextflow using the arguments params file params1.yaml, can I incorporate that in NF test? And feel free to answer that in Slack or go ahead.
I can
and
answer that now. Open an issue on the NF test repo.
All right.
I don't maintain that, by the way.
Thank you so much. So next up, Sebastian is going to talk to us about GWAS analysis at biobank scale.
All right. Thank you. Thanks for the introduction. So today I'm going to talk about GWAS analysis on biobank scale data. And thanks again to Edmund for the shout out to NF test. So I want to start with the most important thing, so the team. So we are from the Institute of Genetic Epidemiology in Innsbruck. And as so many, we are trying to identify genetic risk factors for complex diseases. And what we are actually focusing in our lab for 20 or 30 years is lipoprotein A, which is the most important genetic risk factor for cardiovascular disease. And our team within the Institute tries to tackle these challenges with computational tools and services. So you know Lucas, NF test, Sylvia and Johanna, and I'm very happy that they are all here with us today. So as I said, I'm talking about GWAS analysis. Most of you probably heard about GWAS. It's a key tool in our lab since many years. And GWAS stands for Genome-Wide Association Study. And what we're trying to do there is trying to find associations between phenotypes, like so traits and diseases, and the genotypes, so genetic regions. You see this here in this picture in the case-control GWAS study. We have cases and controls. We are collecting data. We are collecting genotypes. And then what we're trying to do is finding variant differences, allele frequency differences between these two groups in this example. And then you normally get a signal, and this colorful picture, what you see here is a so-called Manhattan plot, where you see on the x-axis the chromosomes and on the y-axis a p-value. As you can imagine, the data gets bigger and bigger. The largest GWAS is currently with over 5 million people included. It's the giant consortium, and many thousands, millions of variants, and of course, different GWAS models and steps included. So you see here in this marked area, which should symbolize the GWAS workflow itself, again, a Manhattan plot. And of course, you have to do things before you're running the GWAS analysis. We learned yesterday a bit about imputation and quality control, and our team, together with the team in Michigan, we developed a system, a software, imputation cloud service. It's called the Michigan Imputation Server, and it allows you to impute your data with this. And of course, our next logical step is now, okay, now we made imputation on the cloud quite easy, and it's widely used, then the next step for us would be, or was, now let's tackle GWAS analysis. Yeah, this slide is probably true for all the pipelines which you have seen here, so it's quite tricky to run the GWAS. At the end, it's a program, a software you download, and then you run it on your data. But yeah, if there's a new student in your lab, like running that on UK Biobank, 500,000 samples, 90 million variants, there are many steps you have to do before you really can run your GWAS model. And then at the end, you're able to run your first GWAS, but still, all these questions, what's in your head, are my results valid, can I share these, how to visualize the data, and all this stuff. So for that, we developed a pipeline, a Nextflow pipeline, NFGWAS, and we really tried to work with biobank scale data. Back then, we decided to go as a first package with Regini, which comes from Regeneron. It's a regression modeling GWAS package, and besides that, we of course also including all possible pre- and post-processing steps within the pipeline. So, and at the end, it really works with hundreds of phenotypes, millions of variants, and we try to parallelize whenever possible or useful. The last months we also focused on restructuring the pipeline a bit into sub-workflows, and here again, NFTest, we used that, of course, and it helped us a lot to do all this restructuring. Quite a quick overview on the pipeline itself. So the marked area in the middle, that's the actual GWAS model. So Regini is a two-step model. So of course we have to execute that. And first thing what we wanted to do is that it works with our data from Michigan, and Regini does not support VCF. So of course we have a step within the pipeline to convert the data into Plink2. It also works with data from UK Biobank, of course, and then you specify your phenotypes, your genotypes, having all these pre-processing steps, and after you're done with your GWAS model, of course, there's things we always have to do, like annotation of the results or lifting over to a different genome build, creating reports, and that's post-processing and also included in the pipeline. You see different colors. We are supporting different modi within the pipeline, single variant testing, gene-based testing, interaction testing, all coming, of course, from the Regini package at the moment. Probably the simplest configuration you can run the GWAS is like this, so specifying just the genotypes, the format, the phenotype, and then hit run. And for example, here we are running a single variant test, the sub-workflow for that, and it executes for you these 13 steps with Nextflow. Okay, so what do you get from us from the NFGWAS pipeline? So we were focusing on biobank scale data, so we really put some thoughts into that. So you get a report which includes all the phenotypes at once, and you see here the Manhattan plots, and as you can imagine, there are 90 million variants, and we had to thought about the binning approach, how we can really have a scalable report within the browser where you can navigate around and browse and highlight different genes, highlight different variants. You see that here in this picture, so we put some thoughts into that. Besides that, of course, you get all the data from the GWAS itself. We are providing other reports, project summaries, significant loci, top hits. It's a start. It's not all what we want to have in future, but I think it's a good start that at least we can work with that in our lab, and it helped us really a lot. Also very important for us is a good documentation. We always do that with our tools, what we are developing. I'm very happy that Johanna, she's also here with us today, she wrote a really nice blog post on her first steps with Nextflow back then, also introducing GWAS analysis, and if you want to learn more about that, please go to our website, and you will also find all the parameters, a getting started guide, configuration, and an FAQ, and also, of course, testing. Yes, parallelization is also a key thing here. We played around with that quite heavily. As you can imagine, the GWAS model itself is the most expensive step computational-wise. And how we do that at the moment, we are iterating over the index files, creating a chunk file, and then you see that in this picture that we are both parallelizing both Regini steps, so step 1 and step 2. Step 1 is a best practice, which the authors of Regini have on their website, and the step 2 is using the chunk file and doing that for all phenotypes at once, and then we're splitting by phenotype later on. We also try to validate as much as possible, so we downloaded summary statistics from the web, from the Penn UK Biobank project. They used a different GWAS model, the SAGE program, and you see here that NF-GWAS against these summary statistics, and for 2 phenotypes here, and you see in this Miami plot, at least what you can tell from here, that the plots with 2 different GWAS models look quite similar or even identical. We also have other validations in our preprint, which is also available on the website. And then we also tested that on Nextflow towers. So shout out to Harshil, who helped us a lot doing that. And what we did is that we ran UK Biobank GWAS with 460,000 samples, 90 million variants, and 100 phenotypes. So that means 100 GWAS analysis via AWS batch with a runtime of 15 hours and a cost of $130. So for us, that's more or less a baseline. So let's see how we can improve that in future. But again, thanks to the Sakara team who helped us move that to Nextflow Tower. Just seeing how much time do I have left. Okay. So going back to software as a service, so now we have quite a nice pipeline, the NF-GWAS pipeline. As I said, it's publicly available. You can download that, you can use that. But our background is software as a service. So we coming from the imputation server, we see all the big advantages what you have when you run that graphically. And that's also true for GWAS analysis, because for GWAS analysis, sometimes you want to have a control, the access to different GWAS data sets, you want to track executions, and also, I'm not sure if that's also true for you, but at least for us, on our campus, it would be nice to have a predefined service and let other researchers at the campus use your service, and you are responsible to configure that with predefined parameters. So our question is now how to provide a NF-GWAS as a web service to the community. And here I go back to the imputation server. So we did that in 2015, and it's quite big, this service. So you see here we have 10,000 users, over 100 million imputed genomes. At the moment, we have a rate of 1 million genomes per month. And we developed that, as I said, with our colleagues from Michigan. And what we are using to run the imputation server is a framework we developed in Innsbruck. So we have NF-Test, we have NF-GWAS, and now the CloudGene framework. And we tried, or what we're currently trying to do is to adapt this workflow to also run with the GWAS workflow. So yeah, that's the current work that we are doing, and it looks quite promising. So we have now our CloudGene framework. What's the base of the imputation server? So it's software as a service, so it's a really specific use case. All the user registration, which worked for many, many years quite well. We used all these features, integrated that in this new GWAS server, integrated in Nextflow support, and then what you basically can do, you can run a software as a service, you install CloudGene, install the workflow, you specify the groups and permissions, and then registered users can submit and track jobs, as you also know that, of course, for others, from other systems like the tower. As I said, that's a bit work in progress. We are working hard on that, and maybe we have the chance on one of the next summits to talk more about these ideas, what we have in mind, and let's see where this goes, where this journey goes. To sum that up, I want to say that really we're doing GWAS for a long time at our institute, but what we have seen is that with this Nextflow pipeline, we just do GWAS nowadays. So we have an idea, let's run it on 5, 6 different models and then have the results right away. We are all coming from different scientific backgrounds. We learned that a good documentation is key for our system, and of course, that's just the start. So GWAS, there are many models available. Regini was the first, but we have a nice structure in the background, so we are able to integrate new features, new models in the future, so feel free to contact us if you have one model you want to see as soon as possible within that. And we're really appreciating the feedback from the community. We are pretty new to this community, but the Sequel team helped a lot fixing bugs and making this run on the cloud. And of course, we would love to hear your feedback also for our SaaS approach. And yeah, that's all from my side. Thanks again.
All right, thank you for a very clear talk. Yes, we have one quick question. Why did you choose Regini, and would you consider support for other algorithms?
What was the second part?
Would you consider support for other algorithms?
Yeah. So as I said, we started with Regini because it worked with UK Biobank. The parallelization of Regini is quite easy to integrate with Nextflow. So we saw a lot of advantages from Regini. But as I said, we restructured that and the pipeline itself, and we are now able to really integrate new GWAS models, also post-processing steps, post-GWAS steps maybe in the future. We really would love to work on that.
Excellent. Well, I think you'll get some more comments on Slack then. Thank you so much. All right. Now my teammate Chris is going to come up and talk to us give us some highlights from the NF Core hackathon that happened earlier this week. Thank you.
There we go. Sorry about that. This is kind of a strange position to be in because I didn't do much hacking at the hackathon. So I'm really presenting everyone else's work. So I want to make it very clear that none of this is my work. All the credit of this goes out to the community and everyone that attended the hackathon and put in the PRs and actually did this work. Talking to people the last couple of days, a few people were asking, what is the hackathon and can I attend? Do you think I'd be able to attend next year? And the answer is absolutely. This is a picture from sort of day one. It's Phil presenting right at the start of the hackathon, and you can see everyone's kind of sitting around the tables. It's a little bit quiet. People are still kind of finding their feet. But very quickly it progresses into something that looks a little bit more like this. And people are sort of helping each other and working on the code together in a really proactive way. It's a really fantastic environment to be in. What eventually happens as well is that people with these common interests sort of start to really find each other and start to work together on the topics that are important to them. And this is just a picture of Harshal standing out the front as they're sort of discussing some of the refactoring they want to do in the NF Core sort of template and the adoption of NF Test. As well as that, there's a lot of fun. So this is just a picture, the only picture I took actually at the cooking event we had the other night, which was everyone at the hackathon. We went in, we cooked a nice big meal together. It's something that's really common for the NF Core hackathons, is that cooking is normally the event of choice. And this is the only picture I took just to send to my partner, just to try and make her jealous. So I'm sorry I didn't take any more pictures, I was having too much fun. The real theme for this hackathon, we don't normally have a theme, was NF Test and how we can adopt this into NF Core and start applying it to the pipelines and the modules and really start, make our best practices even better. And again, I'm sorry, I've completely stolen this from Edmund's slide as well, so you've seen this one before. I do want to highlight as well is that this isn't done in isolation. There's a lot of people that sort of lead groups and help organize this over the weeks and months sort of preceding the hackathon. I do really want to acknowledge all the group leaders that took the time to help their groups and sort of structure everyone to keep everyone moving in the right direction. Especially the people online, so Yuki, Louisa and Abhinav. kind of the unsung heroes who were there online in Gathertown, answering questions and making sure people didn't feel too isolated if they couldn't come in person. So I do really want to sort of give them a shout out, because that's a massive job to take on. Moving on to some of the highlights of the things that were achieved. Again, I've taken this from the wrap-ups of the NF Core sort of every day. There's a daily wrap-up. And I've tried to summarize it the best I could, but as you can imagine, there's such a lot of work that's done in really short succession. So I'm sorry I haven't included names, and if I've left something out, I do apologize for that as well. So the modules and sub-workflows group, they produced a huge number of new modules, and I've just listed some of those here. At the same time, there's this massive drive to adopt NF Test and sort of add this into the modules and sub-workflows as they were getting developed, but also into some that are sort of high usage. Matthias helped me out by sort of making this graph, which is kind of showing the open PRs and the closed PRs and the merged PRs across the 3 days of the hackathon. You can see there in the different colors, we have those that were with and without NF test files. Moving on to infrastructure. So the infrastructure team really works on that NF Core code base, and again, there's a huge amount of work that went on over these 3 days, and I've just taken a summary of that. But you can see here that there's a lot of work on the tooling to make it better, provide more information to the user, as well as things like plugins, so NF validation, there's a new release, as well as like the things that we don't normally think about, like having runners for testing GPUs or modules with GPUs, things like that. The behind-the-scenes work that does definitely need a lot of acknowledgement as well. We were really lucky this year as well that we had Ben and Geordie. They came along and sort of helped with this new group, which is the Nextflow group. So the Nextflow group really worked on part of the Nextflow code base, so looking at things like directives and operators. As well as that, the group included things like documentation and trading, so looking at new material that we can produce to help new people coming along with the community and make sure that they're given the information they need to start working with Nextflow nice and quickly. As well as that, there's a lot of work on plugins. So plugins was a real sort of push again this year. So things like NF CO2 footprint, NF Prov, NF Quilt, all of these were worked on and sort of made massive progress forward. There's a few points there, things like Nextflow Tower with NF Quilt, you can sort of view some data that was produced by that link there. Pipelines was a massive effort this year. Instead of listing all the different pipelines, because there's a huge number of pipelines that were worked on, I've just kind of summarized some of the key ideas that were worked on sort of iteratively across the 3 days. But one of the biggest things was this, getting everyone together to talk about the refactoring of pipelines to accommodate NF Test. Without things like the hackathon, we can't get together to talk about this. Slack is wonderful, but just being able to get people into a room, get around a screen together, talk about how this is going to impact everyone and what we need to do to achieve the next step in the evolution of NF Core in a way. You really can't beat that. Other things like subway maps, of course, applying templates to pipelines, all worked on as well. I took this from the slide as well. Python is very vocal about his, he's not much of a Python developer, and he is very happy to sort of remove some of the Python code and allow it to be taken up by some of those plugins. Right at the end of the hackathon, there was a release of the a pipeline, so the Fetchings pipeline, which had full integration of NF Test. So this is really a proof of concept in a way, showing how this can be used and how it improves the pipeline. I think this will be the first of many that will start doing this in very quick succession. You might have noticed this year as well that there's a lot more stickers. So if you've been coming to the summits and the hackathons for a while, you notice that we've started to sort of produce these hexagon stickers. If you've like me and you started collecting these, there was a new hackathon sticker for the Barcelona hackathon. But we've all started to make these very special, very exclusive stickers for winners of our sort of social competitions. So as normal, we normally have at least sort of 3 main social activities. The first being bingo, where we have a card, and if things happen at the hackathon, which they normally do, so someone uses Sarek as an example, or GitHub goes down, you can sort of cross off those squares. The other is NF Core Sock Hunt, so we hide socks all around Gathertown. It's actually quite daunting being in charge of that because you have people following you around. And within seconds of you hiding this sock, even if it's on a different side of the map, someone has found it. I was really blown away by how quickly people really sort of chased me to find those socks. As well as that, something we started at the last hackathon was the NF Core Scavenger Hunt, where we encourage people to take photos with some challenges, just what they're doing with other people, kind of a fun way to just kind of document what we're doing day to day. Finally, the NF Core Quiz, a game run by Matthias. It's a lot of fun. I think there's definitely a few questions in there that were pressure points to him as he was developing the new NF Core website, which was quite cool as well. Of course, with these sort of competitions, there have to be winners. All of these winners will receive stickers. If I haven't given them to you already, please come and find me after this. I have a whole bag of stickers that I'm willing and happy to give away, as well as that we have NF Core ducks, which I've left out of my bag as well. If you haven't seen those before, they are kind of exclusive collector edition sort of rubber ducks with some NF Core branding, which are quite cool. This is really what it's all about, though, is getting people together into the same space to work on the NF Core code base. This doesn't have to be, of course, you don't have to come and work on NF Core if you're sort of working on your own project, but sort of want to learn more about NF Core at the same time. This is probably the best place you can come to sort of get together and work on your pipelines. But finally, I just wanted to say thank you. Thank you to everyone that was at the hackathon. Thank you to all the organisers, the group leaders, the people that actually did the work, which clearly wasn't me. So yeah, thank you. It's been a lot of fun.
Thank you so much. It was super fun. I started this job on Monday with the hackathon, and it was like the best way to start a job ever. Chris, I only have one question for you. When's your birthday?
That's a terrible question.
It is Chris's birthday today.
Thank you.
So. All right, and with that, it is my great pleasure to introduce our very last speaker for today and for this summit. And that's an easy job because he doesn't actually need any introduction. Evan is going to close out the summit.
Yeah, absolutely. And just echoing what Chris was saying, thank you so much to everyone who's been here over the last days. Like this, it's an incredible event. Every year, it just feels like it gets more and more. Involvement across hackathon, social events, the talks, it's just been really phenomenal. For us as an organization as well as a kind of community, we're now about 75 people or so who are here for the first time seeing this and the impact that we are having essentially from the stuff that people are building. Just incredible to kind of see that, particularly for people who come from not even from scientific backgrounds, to be able to kind of see that and kind of see that the impact that their software is having on all of this. Kind of just a couple of things that I'd like to say thanks to our sponsors. So we have AWS, Memverge, Pixelgen, ZS, Quilt, Oxford Nanopore, Microsoft, and TileDB, and Element. We also, it's a big event that takes many, many weeks and months of planning. And in particular, I'd like to thank the CREA, to the Torre Gloria staff, as well as the AV team. I think everything has gone incredibly smoothly, and it's just a big kind of credit to all of the work and dedication that's gone in so far. So thanks to the team so far. On our side as well, in terms of the community team that we have and the marketing team, so to Noel, to Anna, to Chris, to Geraldine, who did start on Monday, but is very acclimatized very quickly. Marcel, Phil, of course, and to Jake and Monica. They've really been kind of a key part of this and building this up. So thanks to you folks. I guess when we start to think about the amount of work and the amount of time that goes into this, there's two people in particular who have done an incredible job. And I think I will invite them on stage now. I'm not sure if they don't know so, but to Arina and to Anna. So I'd like to invite you on stage. And we have some flowers for you. So thank you so much. Yeah, it's an incredible job. It's so much. And finally, for the thinking about next year and how things are going to be evolving. So we are doing Nextflow Summit in US. Starting from next month. So we're going to be doing this basically in November. It's a little bit crazy to try and do 2 summits in 2 months, but you know. And then next year, we're going to be doing Nextflow Summit in Barcelona. The dates for this will be October 21st to October 25, so basically the same time that we have here. Really looking forward to seeing you all there. Don't be a stranger as well. Reach out in the community. Really looking forward to seeing everyone. And thank you so much for taking the time. It's obviously like very difficult sometimes to travel, spend time away from families, etc. But really appreciate all the time that folks have spent, and looking forward to seeing you around the community as well. Thank you so much. Okay.